I'm Anil Kumar. Welcome to my series on systems of linear equations, where we are going to solve 10 questions based on elimination method. Well, these questions can be solved using substitution method also. Here is question number 6, which relates distance, speed and time. A man travels 600 kilometers partly by train and partly by car. It takes 8 hours and 40 minutes if he travels 320 kilometers by train and the rest by car. It would take 30 minutes more if he travels 200 kilometers by train and the rest by car. Find the speed of train and car. Now, these types of questions are very important from test point of view, and they require a lot of calculations. So we'll at length understand how to solve such questions. Okay. Few things which you need to remember is how to relate distance, speed and time. So that triangle which I'm making here relates distance, speed and time. Distance, let's say d, is equal to speed into time, right? Or time is distance over speed. Now, based on the equation, let us make a sketch to understand how to solve it and how to write the equations. A man travels 600 kilometers, so let's say, so that is a distance of 600 kilometers, partly by train and partly by car. It takes 8 hours and 40 minutes if he travels 320 kilometers by train, so slightly more than half, let's say this much, right? So we are saying that distance covered by total is 600, okay, out of which 320 is by train, so the balance is how much? Just take away 320 from 600, so we get 0. 10 take away 2 is 8, 5 take away 3 is 2, 280. Now, for all this, time taken is 8 hours and 40 minutes. So, time t for us is 8 hours. So, 8 is hours. Now, 40 is in minutes. We need to convert them into 1 unit, right? So, as you prefer, you could do it in hours or in minutes. I prefer to do it in hours, and we are going to use fractions. See how. 8 hours and 40 minutes. 40 minutes means what? 40 in hours is 40 over 60, right? So that gives you time in hours. Is that clear to you, right? So 8 whole 40 over 60, right? Now if you simplify this, you get 8 wholes. 0 and 0 cancel, divided by 2, 2 over 3. 2 over 3, right? Now, we can convert that to improper fractions. 8 times 3 is 24, plus 2, 26 over 3. So that is how you need to convert. This is kind of very important step. And the time now, we have it in hours. Clear? So total time to travel the whole distance is 26 over 3. Now, time is distance over speed. So, let us say that the speed of train is capital T. So, time taken for train is how much? So the time taken by train should be, let's write this equation here. So, this time for 320 kilometers should be, distance is 320, right? 320 divided by the speed of train, right? So let me call the speed of train as S of t, right? Speed of train. Is that clear to you? Plus distance of 280 by car, right? So that is speed of car. Speed of car. And total time, this is the time for each, right? So total time is 26 over 3. Is that clear? So that is how you can actually form your equation. Perfect. Now we know exactly how to make equation from the given situation. So second equation should be what? Let me write down the second equation in a different ink. We now know that It would take 30 minutes more if he travels 200 kilometers by train and the rest by car. So in the second case, let's make it here. In this case, says if he travels 200 kilometers, slightly less than, so we have 200 by train this time, and out of 600, 400 by car. Now, in this case, we need to find time. Time is 30 minutes more than 26 over 3 hours, right? 30 minutes means half more, correct? Okay, so in this case, let's find time. So time, this time is equal to 26 over 3 was last time's time plus half an hour. 30 minutes means half an hour. Is that clear to you? Right. So that gives you denominator of 6, right? So, and when you multiply, you get 52, 26 double, right, plus 3. Correct? So now you get your time as 55 over 6 hours. So that is the time calculation. So in this question, time calculation and working with fractions is very important, which we are focusing on. Now, let's calculate time for train and car. So time for train will be this time 200 divided by the speed of train, which remains same, right, plus 400 divided by speed of car, and total time is 55 over 6. You see that? So we get our second equation. So we have two equations here and two unknowns. Speed of train and speed of car are the two things which we need to figure out. Now, how do we eliminate one of these? So let's decide to eliminate the speed of train, right? In that case, we need to see what to multiply by so that we get the same common coefficient for the speed of time. Okay, so we could do this by doing ladder division method. See, I'll teach you this method to find common denominator. So we have talked about it earlier. Many of you must be knowing about it. We want a common multiple for 200 and 320, right? So I could divide both by 10, so I get 20, and 32. Both I can divide by 4, I get 5, right? And 8. Now we don't have anything common to take away. So the lowest common denominator. So this calculation is for lowest common denominator, correct? So we get here that the lowest common factor, you can say, in our case, will be product of these, right? So which is 10 times, 4 times, 5 times, 8, correct? Now 4 times 5 is 20, 20 times 8 is 116, right? And then 1600, right? So we get this as equal to 1600, right? So that becomes the lowest common factor. Now the idea is to multiply these equations so that 200 becomes 1600 and 320 also becomes 1600. Clear? Okay. Let's see what is the factor by which we can multiply them. So looking into this, 200 is an easy calculation. Let me show you how. 4 times 5 is 20, 20 times 100 is 10 is 200. So we are left with 8. So we are going to multiply this equation by 8, right? The other equation we need to multiply by what? 320, right? So 8 times 4 is 32 and 10, 320 multiplied by 5. So we have to multiply this by 5 to get 1600 as a coefficient for speed of time. Is that clear to you? So what we are doing here is that multiply equation 2 by 8, equation 1 by 5, right? Then what we get here is same coefficient, and then we take away. Is that okay? That is the step. Okay, so let's do it. So now, when you multiply this by 5, what you get here is 1600 over speed of train plus 5 times 280. 0. 8 times 5, 40, 0, 4. You get 1400 over speed of car equals 2. 5 times 6, 33. So 130 divided by 3. Clear? So that is what you get in this case. Here, when you multiply by 8, you do get 1600 over speed of train plus 8 times 4 is 32. 100 over speed of car equals 2. 8 times 5, 40, 44 over 6. Clear? So this is after multiplying by 8. Now we have to take away from this equation that equation. Correct? What do we get? 1600 over st, which is speed of train, cancels. And here you get 3200 over speed of car minus 1400 speed of car equals 2. 440 over 6 minus 130 over 3. Clear? Right? Now you can take the common denominator, which is speed of car. And when you do 3200 minus 1400, what do you get? 12 take away 4 is 8. 2 take away 1 is 1. On this side, now what we need to do is we need to multiply this by 2, right? So what we get here, common denominator 6, 440 minus 2 times this is 260. Correct? So let's do this math now. So what we get here is 1800 over speed of car equals 2. So when you take 260 away from 440, we get 0. 14 take away 6 is 8. 3 take away 2 is 1 over 6. Right? Now you can cross multiply. Speed of car is equal to 1800 times 6 over 180. Correct? Which is clearly, this is 10 times 6, 60. So the values are taken for easy calculations. Calculator may not be allowed for this question sometimes. So we get a speed of car as 60, right? Now, let's figure out what is the speed of train. Now, we can substitute this value of 60 in one of our equations. So we can sub this in equation 2, right? So let's do sub in equation 2, right? There's less space, so I'm just squeezing it in. So we are writing 60 here for speed of car. We get 200 over speed of train plus 400 over 60 equals to 55 over 6. Clear? Now, let us try to simplify this. So what we have here is 200 divided by the speed of train is equal to 55. We have 60 here, right? So 55 over 6 minus 400 over 60, right? Now to make it 60, we'll multiply with 0 in both numerator and denominator. So we get a common term here, right? So now it's easier to simplify. 550 minus 400 is 150, right? So what we get here is 150 over 60 is 200 over speed of train. Is that clear to you? So see how we simplify, taking a common denominator, and now we can cross multiply and get our answer. Is that clear to you? Right? So let's move towards the left side, and we can now write from here, we'll move towards this side, and then we write speed of train, cross multiply then. Correct? So we can write speed of train is equal to 200 times, so when you go to, so 60 divided by 150. Clear? So you can now simplify, cancelling zeros, and both can be divided by 3 and 5. Correct? So by 3 we get 2, and 3 times 5, and 5 goes 40 times. 40 times 2 is 80. Is that clear to you? Right? So we get our answer, and that is the speed of car is 60 kilometers per hour, and speed of train which you say ST, is 80 kilometers per hour. Is that clear to you? Correct? So that is how such questions can be solved. I will like your attention on this since we are working with fractions, which at times is difficult for many students. See how we use the concept of common denominator most of the places. We did not really simplify to the lowest terms, but we looked for common denominators, and that helps, right? That helps. So that is how we are going to solve similar questions. I'll provide you with a link on many such examples relating distance, speed, and time, as this is a critical question for many test papers. Now here is question number 7. Peter rows 12 kilometers downstream in 3 hours. On the return trip, it takes him 4 hours to travel 8 kilometers. Determine the average rowing speed and the speed of the current. Okay, so let's say that's the river flowing, right? And we are saying that the speed of the current is SC, right? So that is always in one direction. Now we have two scenarios. One of the scenarios is going down 12 kilometers, right? So during this time, let's say the rowing speed is constant, we say rowing speed is SR. Now, this is a distance of 12 kilometers and time is 3 hours. So that gives you the equation which we are looking for, distance, speed, and time, right? So we are always looking into this triangle to relate distance, speed, and time. So the distance of 12 kilometers is equal to speed into time. Now what is the speed? Now these two speeds, when you are doing in the same direction, add up. So speed is speed of rowing plus speed of the current, and the time is 3 hours. Clear? So that becomes your equation. You can divide by 3 and get it in simpler form. So 4 is speed of rowing plus speed of current. Clear? We'll call this as our equation number 1. Now, let's look into the second scenario when Peter is returning back. So in that, he is able to do 8 kilometers in 4 hours. So returning back, let's say 8 kilometers, time is 4 hours. That's it. Now in this case, the speeds are going to be opposing one another. Is that clear? So in this case, what we have is distance of 8 kilometers and speed is going to be the difference of the two. Speed of rowing minus speed of current, and time taken is 4 hours. You can again simplify. We get 2 equals to speed of rowing minus speed of current. So we get our second equation. Correct? 2 equations, 2 unknowns, we can easily eliminate by adding them up. So we'll add equation 1 and equation 2. When you add, you get 6 equals 2. 2 times speed of rowing, right? So we get 6 divided by 2, which is 3 as speed of rowing. Clear? So once you get one of the values, you can always substitute that and get the other value. So that is the strategy. Correct? So now we know that speed of rowing is equals to 3 kilometers per hour. We'll substitute this in one of our equations to find speed of current. So we can use equation 1. So we'll sub in 1. So we know speed of current will be equal to 4 minus speed of rowing, which is 4 minus 3, and that gives you the value as 1. So we get speed of current equals to 1 kilometer per hour. Is that clear to you? Right. So we get both our answers, and the answers are speed of rowing is 3 kilometers per hour and speed of current is 1 kilometer per hour. Clear? So that is how we are going to solve it. Now let's take the next question. The sum of numerator and denominator of a fraction is 4 more than twice the numerator. If 3 is added to each of the numerator and denominator, their ratio becomes 2:3. Find the fraction. So let the fraction be what? Let's say numerator divided by denominator. Let's say n and d. So numerator divide by denominator. Now, let's try to write down the equation. It says sum of numerator and denominator, that is numerator plus denominator, is 4 more than twice the numerator. So we'll do 2 times numerator plus 4. Okay, so let's reorganize. We can always write this as bringing 4 to this side, minus 4 equals to 2n minus n minus d, or minus 4 equals to n minus d. So that becomes our equation number 1. Now let's look into the second condition and find the second equation. If 3 is added to each numerator and denominator, that means numerator plus 3, denominator plus 3, their ratio becomes 2:3. Clear? So we get our equation. Now we'll cross multiply and get the equation. So 3 times numerator plus 3 equals to 2 times denominator plus 3. 3n plus 9 equals to 2d plus 6. Again, let's bring them together. We get 3n minus 2d equals to 6 minus 9. So we have 3n minus 2d equals to minus 3. So that becomes our second equation. Now how do we eliminate? Well, to eliminate, we can multiply equation 1 by 2. Right. So what we will do now is we have to make the same coefficient. So we'll multiply this equation by 2. So we get 2d minus both places. So when you multiply this by 2, you get minus 8 equals to 2n minus 2d. And we'll call this as our equation number 3. Okay? Now we have minus 2d and minus 2d we can take away. So we will do equation 2 take away equation 3. So when you take away from 3 and 2n, you get n minus 2d 0. And from here we get minus 3, take away minus 8. So n is basically minus 3 plus 8, or 5. So we get the value of numerator as 5. Now we can use one of our equations and find the denominator. So we'll sub this, sub n equals to 5 in, let's say, equation 1. So if I write 5 here, I get minus 4 equals to 5 minus d. So it becomes d equals to 5, and then 4 comes this side, becomes 9, right? So d is 9. So now we know that numerator is 5 and denominator is 9. Find the fraction. So our answer here is, fraction is what? Fraction is 5 over 9. Clear? So that is how we are going to solve this question. Let's move on and take the next question now. This is also number based. A number consists of 2 digits. When the number is divided by the sum of its digits, the quotient is 7. If 27 is subtracted from the number, the digits interchange their places. Find the number, right? So this is number. Okay. So let's say that the number is PQ. So we are taking number as, let's say, P times, that is our number. We need to find what is P and what is Q. These are the 2 digits, right? This is 1's place, this is 10's place. When the number is divided by the sum of its digits, the quotient is 7. How do we write this equation? When the number is divided by sum of its quotients, sum of its digits, quotient is 7. So the number is what? Number is 10 times P plus Q. That is the number, right? Divided by sum P plus Q. The quotient is 7. Is that clear to you? This is very important to understand, okay? Now, we can cross multiply. So we get 10P plus Q equals to 7P plus 7Q. Bring them together. So left side, okay? 10P minus 7P. And we have plus Q minus 7Q equals to 0. So we have 10 minus 7 is 3P. And Q is minus 6Q equals to 0. Okay. So we get one of our equations. Second one, if 27 is subtracted from the number, the digits interchange. So the number is 10P plus Q minus 27. So that is 27 subtracted from the number. Digits interchange, so it becomes QP, right? So it becomes 10Q plus P. Does make sense to you, right? So again, let's bring them to one side. We get 10P minus P plus Q minus 10Q equals to 27. Okay. Now, so we get 9P, and as far as Q is concerned, minus 9Q equals to 27. We can divide by 9, so we get P minus Q equals to 3. Okay. Here, we could divide by 3, right? So we get P minus 2Q equals to 0. So we'll call this as our second equation and this one as our first equation. Clear? Now we can eliminate P or Q. Well, let's eliminate P by taking away, right? So we'll do equation 2, take away equation 1. So P and P cancels and we get Q equals to 3. Clear? So we get Q equals to 3. Now when Q is 3, we can substitute this value and find what P is. So P is equal to 3 plus Q, which is 3 plus 3, which is 6. Correct? So we get our answer. So the answer is that the number is 63, right? So the answer is 63. Clear? So P and Q, so the number is 63. So that is how you're going to do it. So I hope that makes sense. Now let's move on and take the last question in our series of systems of equations. Question number 10. A pipe can fill a tank in 1.5 hours, and another pipe connected to the same tank can empty the tank in 4/5 hours. In how much time will the tank be 1/4 full if both pipes are turned on at the same time? So let's try to understand the situation. So we have a tank here and we have one outlet. So that is the outlet. And we have one inlet here. Okay. We are looking for a situation to fill in 1/4 of the tank. We are given both the rates. So for the whole tank, it takes time to fill as, we'll write time to fill as 1.5 hours, which is 3/2 hours, correct? Now time to empty, let's say E, is 1/4/5 of an hour, which is 9/5 hours, right? Now, when we say empty, we'll use a negative sign. So in how much time will the tank be 1/4 full? So let that time be T. So in time capital T, tank is 1/4 full. Correct? So that is the condition given to us. Now how do we solve such questions? Whenever you have such questions which are related to rate, right? So the rate here is 3/2 per hour, right? If T is the total time taken, then the equation becomes total time divided by the time taken to empty the whole tank, which is 3/2. Since this is to empty, that one will be negative. It works for the same time T and get 9/5, and the result is 1/4 of the whole. Correct? So that is how you get your equation, right? And now we need to simplify this. So you can write this as 2/3t minus 5/9t equals to 1/4. So let's make common denominators. We need to multiply this by 3, right, to get it. So 3 times 2 is 6. 6t minus 5t/9 equals to 1/4. So that is t/9 equals to 1/4, or that gives you the time as 9/4, right? So now you can divide this 9 by 4. So 2 hours full and 1/4, right? So that many hours. It will be quarter full. Is that clear to you? So that is how you are going to answer this particular question. So in hours, 2¼ hour, or you could say quarter of 15 minutes, that is, so 2 hours and 15 minutes. So that much of time it will be quarter full. So with this we come to an end of our set of 10 questions based on linear systems. All these questions were solved using elimination method. Well, for most of them, elimination method was a preferred method, but for some, you could always use substitution. I hope you've understood all these steps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.